Good morning, everyone. My name is Sachin, and I'm submitting this assignment for the course CML 661 to Dr. Sujesh P. Thomas. So, without any further ado, I'd love to start my presentation on this particular assignment. So, in this assignment, we had to solve three different structures, crystallographic structures, using the data that was provided to us in the INS and HKL file. The HKL file mostly harbors the informations about the Miller planes and the different reflection peaks, the intensities, but the reflection peaks intensity weren't given to us. So we are opting to the direct method to like try to figure out the structure of a particular crystal, a particular XRD pattern, and along with that, we are just defining the models, and along with that, we also have to generate the PXRD pattern, also have to visualize the structures that we have made using the Vesta software. So that's the general overview of this particular assignment, and the data one that was named as the SCT file that was provided to us. My name is Sachin, so let's get started. So I'm unable to record my laptop screen, so I have just converted everything into a PPT and taken down some snippets of the process, the during the process, so that I can show you what I have done in the steps. So number of steps I have reduced down. So in we are using the software OLX2 software, which is an open source software, and it usually shows the structure based on direct method or refinement. And this is how it looks. This is the user interface of that particular software. I have loaded the sct.ins file, and I just went to the work, then sol, then I get an initial structure, initial electron density plot, not plot, electron density scatter, I can say. Then I try to assign the, it's like a hit and trial kind of method. So I found that there is six electron densities that are there, like these ones. So I assigned them as the carbon because carbon they form six member or five member rings. So this was the initial seeding for my particular structure deduction. Then I went to and I saw, then I reduced down, then I use my like try to see like where the electron density is more condensed or less. And as we know this in the structure we have two sulfur atoms, sulfur being the highest. Sulfur has the highest atomic number, so its electron density is of course going to be the highest. So assign this particular atom as sulfur and its nearby atom, sorry, this particular atom as sulfur and chlorine because they have like nearby electron density because there's chlorine as well there. Then on to the next step, I assigned some more electron densities, more atom types like nitrogen was there, and then another sulfur was there. Though the structure we sold in the class told us how to solve the structure during the tutorial, so it was a bit easy. We know that's how to solve because we already knew the structure. So I'm not going to go into that much depth of it. Then we use the sulfur and we all know SO2 exists, and then assign to the nitrogen, NH3, NO2, and H2, and then finally we use the spherical instead of spherical we went to the ellipsoid model to take care of all the thermal vibration ADT parameters. Then at the end we had this structure, this particular final structure we got, which has the R value, root mean square deviation value is 3.57. So it's if it's less than 5, so it's close to good. Like we it can be 100% wrong, but it is like good assumptions, good model prediction that we have gotten out of our scln.ins file. INS file is mostly used for as an input file for the OLX2. So the compound which I identified as which was named as the SCT hydrochlorothiazide. The similar steps we are going to follow for the second compound. But before that, we had to visualize it into the Vesta software, and this is how it looks. As you can see, these yellow color atoms are sulfur, then green are chlorine, then sulfur. Six member ring is there, and there's nitrogen, this gray color, and there is again one nitrogen here. So this is how structure is visualized. This is a monoclinic unit cell because it was mentioned in its parameters in its acid HKL file and INS file, monoclinic, and we could also deduce that from alpha, beta, gamma, and ABC, this unit cell parameters. So it was monoclinic. All three structures that I have deduced, they all are monoclinic. Now this is the predicted PXRD pattern for this particular chlorothiazide, hydrochlorothiazide moiety. And as you can see, the like peaks are almost negligible after 2 theta, this value of like more than 50, 55, but there are like certain very sharp peaks we can see. Like there are in this particular region, there are sharp peaks at the low value of the theta. means the lambda values, of course, lambda value is of course going to be high because of theta is low. And using the simulated PXRD pattern, we could analyze the bulk samples. Like if we are a pharmaceutical company and we produce a drug, let's say I have to produce this hydrochlorothiazide and I have to check for its purity. I can just take its PXRD pattern and try to match it up with this particular simulated or predicted PXRD pattern from the Vesta. If it exactly matches, then on the peak, so means it's close to pure. Not 100% pure, but close to pure. It just could also be wrong though. That data too, it was nomenclatured as RMAL, though the hint was provided to us by the sir that it's a riluzole drug is there, and this is malic acid or malonate. This is what we had to figure out. So initially, the same thing we have followed, and this is how the structure that I loaded looked like. Then into the next frame, I somehow found the pattern that there's a six-member ring here somewhere, and then there is an there's a sulfur atom here, nitrogen atom here, and then along with that there's an oxygen because there's a CF3 moiety is all of course in this particular drug that exists. This moiety exists. This is the fluorine, carbon, oxygen, and this is remember our benzene ring we have. Then in five member ring we have. Then similar to this pattern, like we our R value like is still high, 45%, 45 not percent, 45. Then we kind of solved this the riluzole moiety, and but there still remain the question, which is it's a malic acid malonate. This is what we had to figure it out. So initially, what I was thinking that maybe it's linked to this particular moiety, but it is not. They are in a hydrogen bonded state. This is the final structure that I deduced. Like this, these are the oxygen, hydrogen. This is carbon. This is OH. This is malonate. The structure looks like this: double bond O, double bond O, OH. The negative charge here, this particular, and they are in the hydrogen bond with this hydrogen. So they exist in a closer because six member ring is forming here and six member ring is kind of forming here. So they are in a like very stable conformation, stable structure. Their R value is 3.1, 3.7, and there's the compound that I identified is a riluzole malonate compound. This is the how it looks like in the Vesta software. As you can see, this we have the six-member ring, and along with that moiety, we have oxygen, fluorine, sulfur, all the different kind of hydrogen bonds, and the ion induced interactions are also there. Dipole induced interactions are also there. This is the PXRD pattern of this particular drug looks like from the Vesta softwares. As you can see, there is a number of sharp peaks that are quite more than the hydrochlorothiazide drug. But like after a particular theta value, they like the intensity of peaks dips down. Then the third drug, which was also nomenclated as ROPA, ROPA, this is the same moiety, riluzole moiety, same works pattern. I loaded it, sold it, and there's this six-member ring that I identified because most of the organic drugs that we got, they have either some rings like six-member, five-member rings. This is what we have to do. If even if I wouldn't have like got this the six-member ring, I would have like just did the reverse engineering. As you can see in the formula, there is a phosphorus there, sulfur there. So if the highest electron density atom या spherical moiety would have been sulfurs, I would have assigned it, then refined it again. So I would have gotten like the structures. I would have like started from one singular atom or one particular ring. Doesn't matter because I've tried both ways. I started from sulfur and got the full structure. I started from this particular benzene ring, still got the full structure. So that's up to the person how they are solving it. This is just the final rendition of it. Before like getting these slides, I had like I, at least took me 5-10 iterations for each particular moiety, each particular drug. So yeah, six-member ring we are getting here. So I'm starting with this only. Then, as you can see, there's a this particular oxygen atom here. Then there's a if I refined it again, I found that oh, there's a carbon atom. This CF3 moiety is still there, and again, this R value is so high. Again, the riluzole moiety are still formed again after refining it and assigning key hit and trial method. I'm just using it. Then the most difficult part was whether it's a phosphate or hydrophosphate, dihydrogen phosphate, orthophosphate, what it is. Like this is what the main question was. At the end, I found that it is S2PO4 negative, and this This particular has to be NH3. There has to be one more hydrogen. So the software actually confuses between NH2 and NH3 positive because for the charge neutralization method, because we have to neutralize the charge, there is a hydrogen that exists here as well, so that it can form hydrogen bonding with this moiety. And there could be ionic bonds as well. It could be any compound as well. Riluzole having the like positive charge and the H2PO4 having a negative charge. There could be like this as well, or it could be just simply neutral moieties could also be there. Both possibilities are there. If it's NS2 simply, then it's just orthophosphoric acid. But I think orthophosphoric acid, they're just two different separate moieties. They could form hydrogen bonds, but the ionic bond between those has to be more strongest. And body being the water, they are more soluble in the water. So keeping the aromatic properties into the mind, I think the this is like this NS2 moiety is actually NS3 moiety, and this is the S2PO4 negative dihydrogen phosphate. These are the moieties that we got, and the final value of R is 3.31. And then I use this before like assigning the hydrogen atoms. Before assigning the hydrogen atom, I also took care of this ADT parameters into the mind so that the thermal vibrations could be minimized. And after some small tweaks here and there in the structures, I got the final substances as riluzole dihydrogen phosphate, which is this particular moiety. Here's the riluzole. There's a positive charge, and dihydrogen phosphate is here with a negative charge. So charge balance method has to be taken into care because body being the polar moiety, so they have to be more soluble in the body. This is how it is visualized into the Vesta. This is the unit cell of this particular Ropa moiety, Ropa compound, and it is also monoclinic. And we can see some like hydrogen interactions and the ion-ion interactions as well here and there into this particular moiety. So this is the predicted PXRD pattern. There's a very, very sharp peak close to 7 degree or 2 theta value. And this structure, this particular simulated PXRD pattern is very, very different from the previous SCT, RMAL, and the ROPA. They are just a simulated PXRD, like how it should look like in the ideal cases. But in the in the reality, they could differ actually. Some peaks could be here and there, some impurities could be here and there. So thank you everyone for listening to me. Thank you everyone. Have a good day. This was me, and I'm submitting this assignment to Dr. Sujesh P. Thomas. Thank you so much, sir, for giving us such a intriguing assignment. Such a like, I really enjoyed this assignment. To be honest, it was like a game actually. Thank you so much. Have a good day, everyone.